Hi everyone. So today we will cover the scenario of we will try to understand where the cloud comes into the picture, correct? What's the use of the cloud and why did it came into the picture? That we will try to understand here. We will take some lemon examples as well. So yeah, let's go with that. So suppose that let me clean all these things. So suppose that I have deployed one application, correct? And that application is serving some end user, like it's a e-commerce website of where I'm trying to sell clothes, my branded clothes, correct? So this is my one of the, I will say that this is one of my uh, server, physical server, correct? So on this physical server, I will be deploying my application. So just suppose that my application name is that manishclothing.com, correct? So this is the application, and this application is being hosted on this physical server, correct? And on this physical server, my application is running, and it has some features like it has some cart function, just like the e-commerce website, correct? So it has the card system, then it has your profile system and all those multiple things, correct? It has card, it has then your uh sorry, it has your profile section, then it has something your called as, let me put it here, profile, and then what can be this is things order, and then it has something as a payment service, correct? Payment service will also be there in your e-commerce website. So it has multiple service which are running on this physical server, and overall it's manishclothing.com, which is serving your application response, and it's serving your business nets, correct? So suppose that the time I launched this my application, it has 10 users, correct? It has started with the 10 users only who will purchase the items from this machine. So I will require only one physical server, correct? So I will require only one physical server here. And this physical server is ready to serve the purpose of this 10 users, correct? It will serve that I can say that request, correct? So once it has served this 10 users, so I won't be able to serve more than 10 users, correct, with this physical server. Suppose that tomorrow I have more than 10 users. I have this thousand of users, correct? I have just suppose that I have this thousand of users rather than 10 users. Then on after that this day I have more than a thousand even. I have become my brand has been a very large, correct? So it has been 1 lakh of users. So this one physical server will not be able to serve the response for all these users, correct? It will require more number of physical servers as well. So I will have to do create multiple physical server here, correct? I will have to create more physical servers. So one physical server, then the second physical server, the third physical server. So I will require more and more, correct? So I will require physical server for 1, 2, 3, and 4, all these physical server unit, correct? So to get the response to serve the purpose, like everybody is ordering, somebody is doing payment, somebody is doing checking their card, somebody checking their profile, and all these things are happening, correct? So they require more number of physical servers. And it might be that on a festive season it has been 1 lakh of users, but just after the festive season it's again become the thousand users only. And you have purchased these physical servers for your business nets, correct? These two physical servers will be of no use after the festive season. So the requirement is that you don't have to use your physical servers every time, correct? It will vary. The requirement of these physical servers will be vary on basis of the how much traffic your application has, correct? So that will be there. So it has to be something that will save your cost, and it will do the things whenever there will be a requirement, correct? If I don't require the physical servers, it should not be there. So that kind of thing we require, correct? Or taking a lemon example of that, correct? So you are residing somewhere in Delhi, correct? Or you are residing somewhere in Bangalore or support. So I will be taking the example of Delhi. So just suppose that you are living here in Delhi, correct? You are here in the Delhi. Just suppose. So let me take another tab here. So just suppose that you are living here in Delhi. correct? And somewhere or some due to some reason you have to go somewhere at Bangalore, correct? Just let me do. Okay, you have to go Bangalore due to some reasons. You have a business meeting or you have to do your job there. So you are currently here in Delhi, you have to go to Bangalore. So what will you do? Will you go there in Bangalore? You will just purchase a house and then you will sit there and you will work for 2 years and then you will come back to your home. You won't do that, correct? You will go from Delhi to Bangalore. You will go from here and you will be doing that kind of a stuff like you will come to here Bangalore and you will rent a house and then you will pay the rent amount and till the time you will be there you will be paying the rent and once your work is done there you will come back to your hometown Delhi, correct? So that you will do. In the similar way, uh, here we talked about the physical server. So the moment we will require to serve the 1 lakh of users traffic, we will purchase we will purchase some servers. We require that kind of thing. And once our purpose is fulfilled, we will return back the physical server. So that kind of thing we require. So there's cloud comes into the picture, correct? So taking the example of this home, you might have understood. Or taking the example of Ola and Uber cab, correct? So you do, to go from one location to just suppose Delhi to Bangalore, you don't have to purchase Ola or Uber cab, correct? Or you don't have to purchase the flight or the train itself. You can book a ticket and you can go there. So till the time you had requirement, you just purchased and you paid the rent for that and you avail the service of that. So that's where you can use the cloud concept. So cloud comes into the picture to give you the services of pay as you go, that kind of model, correct? So what it does, it's the what is cloud computing model? So it's all modern computing uses a basic client server model. Let me go there on full slide. So you will be able to see the things. Okay, all modern computing uses a basic client server model. A client can be a web browser or desktop application. Client makes a request to the server like this is how cloud computing model works, correct? What is the difference in on-premise and cloud? Application will be deployed on virtual machines, data centers managed with the cloud providers, while in the on-premise you have to application run on computer system, need to set up, manage and maintain these servers, correct? There should be some team which will manage their these servers, correct, which are your physical servers. But here it will be the cloud provider who will manage your web servers. Once your VM is stopped or it has been terminated due to some reasons from the cloud itself, so it will manage automatically. Correct. Then you can see the data centers which were before. Correct. So these kind of hardware devices and all these physical machines were there in the data centers. But before the cloud, what were the scenarios and what were the challenges we talked about? So it needs the infrastructure to deploy their applications, peak usage during holidays and weekends, correct? So it might be on the festive season, it might be a very high traffic, and just after the festive season, there will not be traffic, or it will be just a normal traffic, correct? So that kind of scenario can be there. So you will have to procure or buy infrastructure for peak loads. Just suppose that there is a particular festival which is coming in there. So just for basis on your assumptions that how much traffic will be there, you will have to purchase the physical server based on the need. So it will result in high cost of procuring infrastructure. Correct. Even if you don't require thousand number of physical server, you will have to purchase in advance, and that will be of no use. So it's a high cost of procuring. Need ahead of time plan. You will have a team to plan that traffic load. You will have lower infrastructure utilization. Whatever you have purchased is not required after 1 week, and dedicated infra maintenance team. So as it's a physical server devices, so you will have to have a team who will manage your infrastructure, correct? So that kind of thing. So to overcome the challenges, there multiple cloud provider or the cloud vendor came into the picture. They started their businesses, and one of them leading is the AWS one. Then there is Microsoft Azure. Then there is a Google Cloud. This one, and this is the AWS provider. Then this is the Microsoft Azure. Then there is a Salesforce. Then is Oracle, IBM Cloud, and other cloud providers are there into the picture, correct? Yeah, what is the advantage of cloud? So stop spending money on running data centers. So you don't have to go for the data centers. You can use the cloud provider and you can run your servers. You can benefit from massive economic of a scale. You don't have to go for a scaling based on the like pre-assumptions. Whenever there will be traffic, you will go for the your scaling, correct? Go global in minutes, that within a minute you can launch your physical server either in Mumbai region or in your Ohio region or in a Singapore region or Sydney region, wherever you are sitting and you want to serve the users of that region particularly, you can create your issue machine so that it will be having less latency. It will serve content on a more faster pace, correct? So you can go global in minutes. Increase speed. So as you have very less time to start, correct? You can within a minute you can start your EC2 machines, you can deploy your infrastructure, that kind of thing. So you will have option to speed up your things, correct? So that you can do. Stop guessing capacity. You don't have to plan in the like you don't have to plan for future. Whenever there will be requirement, you can just based on the requirement, based on the traffic, you can create your infrastructure and you will be able to serve the traffic. So you don't have to uh, guess for the coming traffic, correct? Then this is the what is AWS particularly. So it's a Amazon Web Service, leading cloud provider. There are multiple web services: AWS BPC, AWS RDS, Secret Manager, IAM role and policy, Lambda function, and etc. Okay. And what's the model of this AWS cloud provider? So pay only for what you use, that we talked, correct? So to the time what you have use the infrastructure of the AWS, you have to pay for that amount only. And after that, you can terminate and you will be free of, you don't have to pay anything, right? So these are the AWS data centers in the movie. This is the one picture I have taken from the internet. So, okay, so getting started, we will leave this accounts and I'm directly coming to the Elastic Compute Cloud. So we will cover just basic of AWS Compute class AWS Elastic Compute Cloud EC2 service. So you can see in corporate data center, applications are deployed to physical servers, but we are talking about the AWS cloud. So it's the virtual servers. EC2 instance is nothing but the virtual server where you deploy your applications in the cloud. So these virtual servers are basically somewhere hosted on the physical server. So for the AWS, like we are able to see this virtual server only, but somewhere in the background, these virtual servers are running on the physical machines, and those physical machines are at the AWS data center, correct? But we don't have to worry about that physical machines. We are just worried about the physical virtual server as we are the customer for this AWS cloud, correct? So yeah, our application will be deployed on this virtual server. Then we can attach a storage as per our need and our EC2 instance. We can manage the network connectivity. We can do the load balancing like just suppose that I have a physical server one, I have the virtual server one, two, three, and then I have the four. So I can redirect my traffic on the first, then based on certain condition, I can direct it to the second, then I can on the certain condition, I can direct my traffic to the third, and then on the certain to fourth condition, I can direct my traffic to the fourth server. So that kind of thing I can do. I can do auto scaling, correct? So initially my two servers will be running, only these two servers will be running, virtual servers. And as and when my traffic goes from 100 to 1000 or lakhs of users, I will be running more servers. So it will be automatic scaling, correct? So that kind of thing we can do. Okay. So pay for what you use. Let me go for the eraser also. Yeah. Okay. So pay for what you use, correct? So we have to pay only for the time being. We are using the AWS EC2 machine, and then we can attach a EBS Elastic Block storage for storage, correct? For the storage system. Then there are multiple instance class of the EC2, correct? It's general purpose. It's the type actually. General purpose EC2 instance, then compute optimized, then the memory optimized, and the accelerated storage optimized. So you can see the details of this, like what are the type A1 and general purpose are of T family, T3 micro, T3 medium, and all those kind of things. You can see what is the mnemonic symbols for that. Like for the P is for the picture, C is for the compute, R is for the RAM. So the EC2 instance, which is a memory optimized, that will that R5 or something kind of thing, R family, correct? R5 or something. So it will start with the R. If you are using T3, T2 micro, so that will start with the M, your correct micro for M and all those things you can see. So you can check all the details here. Then, like just suppose that if we are writing this T2.micro instance for iOS, correct? Great for a diversity of workloads, such as web servers for code repository. Balance. So this general purpose EC2 instance is balanced between these two. Sorry, these three: compute, memory, and networking. It has balanced resource allocated to this kind of EC2 machines. Right. Then talking about this compute optimized. Let me remove this. Okay. So great for compute intensive tasks. It's a batch processing workloads, media transporting that it will help. This is kind of EC2 instance can be used in this purpose. And the name of this compute optimized instance starts with the C. C5.x large or C5.large, those kind of EC2 machine are the compute optimized. Then there is a memory optimized instance. What is the use case? So it's the fast performance for workloads that processes large data in memory, correct? So it's a high performance, the use case, distributed web scale, and this kind of EC2 instance can be used for the relational database or non-relational database as well, because the database requires the high performance, correct? So application performing real-time processing of biggest unstructured data. That for that purpose, also we can use the memory optimized. And name starts with the R, correct? So R stands for the name here also. So we can check on this. Okay, then there are storage optimized instances. So what is the use case? So it's great for the storage intensive tasks that require high sequential read and write access to large data sets on local storage. What's the use case? So it's a high frequency online transaction process system, relational and NoSQL database, Redis and open source memory in data store that can be used as a dataset, cache, or message broker. It's often used by caching web pages and reducing load on server. So this particular kind of EC2 instance, the storage optimized, can be used for the Redis, correct? If we have to use the feature of the Redis, correct? So Redis can be installed on this kind of EC2 instances. The storage optimized instances starts with the name I, correct? What are the types and the examples? Like to, if you have to get the further information on the EC2 instances, you can visit on this website and it will show you the detailed information, the CPU, memory, storage, network, and the ABS bandwidth. So as you can see, for two or three instances, I have noted down the CPU memory. So for T2 micro, it's CPU 1, memory 1, EBS storage can be attached, and the network performance is not low to moderate, correct? That kind of thing you can see. Okay. And the similarly is for the C5.xlar, it's the 4 CPU, 8 GB memory, EBS only. That's the storage, and up to 10 Gbps network performance it will provide you, correct? So what is this T2 micro, all these kind of things? So here, here, if you see T stands for the instance class. So this is the instance class. As we check the storage optimized, memory optimized, compute optimized, and all those. TIR, all these things, these letters stands for the your instance class. Two stands for the generation, of which generation these instance classes are. This particular instances. So this two or T5, C5, all these things stand for, like there is an instance C5, correct? C5 dot X large, correct? And that is the one of your EC2 instance, correct? C5 dot X large. So this 5 will stand for the generation. This 5 is generation. This is C is instance class. And other this one stands for the size. Stands for the size. Similarly, if you can see here, micro stands for the size within the instance class. Similarly, T3 medium, C5 X large, and so on. What is the elastic block storage? So elastic block storage is your service, one of the AWS service, which is provided by the AWS itself, and it allows users to store and manage persistent block level storage volumes. So this ABS elastic block storage can be attached with your AWS EC2 machine. And what are the features? So it gives you the storage volumes, can be used like a local hard drive to store file on installed application. Snapshot, so you can take the snapshot of elastic block storage, and with the snapshot, you can recover the data, correct? So it will help you to disaster in the disaster recovery, data migration, or the backup compliance, correct? So in the backup also it will help you. That means that suppose that this is your EC2 instance, so you can attach your EBS volume, this one EBS you can attach to this EC2, correct? Just suppose that this is your EC2. So this EC2 can be attached, like this EBS can be attached with your EC2 machine, and it will have all the data written over here. And this data can be once in the case of DR, if this EC2 instance get crashed or it got terminated due to some reason, so you can attach this EBS block to some different EC2 instance, and it will have the same data what it had, correct? So you can have the backup plan, backup kind of thing, or the disaster recovery kind of thing. It's encrypted with Amazon KMS key, and the volume times, it has the SSD volumes are optimized. Like you can see volume times, what kind of volume type it provides. It provides the SSD, it provides the HDD. So this type of volume types it provides. So you can use of that type of EPS volume, sorry, general purpose provisioned IOS that you can see. So, so later on, we will talk about the security group and other things. But till now, we have talked about the EC2 instances, and I hope this is helpful for you. So we'll see you in the next video with the security groups and other detailed information about the related to the EC2 only. Okay. So that's it for today. Thank you.